Just breaking down this plywood to get it into a little bit more manageable sizes so that I can start ripping the pieces for the drawer sides, fronts, and backs. So now I've got 4 pieces. Each one of them is a bit more manageable than a 4x8 sheet of plywood, and I'll feel just a little bit safer putting these on the table saw. When I broke down the plywood, I broke it into 4 pieces. The first rip cut that I made was at 23.5 inches. That's because that's the width plus a little bit for the saw kerf for 3 different cuts was what I needed to make the 3 drawers in one side of the cabinet. The 24.5 inch piece that's left over will be what I need for the 4 drawers in the other end of the cabinet. So I'm going to start ripping. I'm going to rip the deepest drawer parts first and progressively get to smaller pieces as I go through. When I first broke down my plywood, I ripped it lengthwise and then I cross-cut it into smaller chunks. My first cross cut was at 50 inches, leaving me one 50-inch piece and one just a little shy of 46 inches out of each piece. I then ripped all the pieces to the correct width, making the height of the drawer boxes. Now I'm going to cut the sides, the fronts, and the backs to length. Now in drawers A, B, and C, the front to back length of the drawer is 24.5 inches. So I'm going to cut the 24.5 inch pieces out of the 50-inch long boards that I cut. To do that, I've set up a stop block on my miter saw, and all I've got to do is cut. The next cut that I need to make is to cut the fronts and backs of the drawer boxes A, B, and C to length. Now the fronts and backs of the drawer boxes set the width of the drawer, and the drawer slides that I'm using don't have much tolerance. They allow +0, -1/32 of an inch. So that's very little tolerance, so these dimensions have to be absolutely dead on. So again, I'm going to measure carefully, set up my stop block, and cut the fronts and backs to length. Okay, I've got all the drawer pieces cut out to width and to length, the fronts, backs, and sides of all the drawers. And because these drawers are just 17 inches front to back, I wound up with these scrap pieces which are the same width as the corresponding drawer. I'm going to take these scraps and I'm going to cut them in half. I'll show you in a minute what we're going to do with that. Alright, so what I'm doing right now is I'm mocking up each drawer just to get the orientation of the plywood the way I want it. Now if this was some fine lumber, some fine hardwood lumber, it would really make a difference as to which were the show sides. That doesn't matter so much on plywood, but what does matter is I'm looking for obvious flaws. Voids in the cores of the plywood, voids in the ends in particular that will mess with my box joint joinery. So once I get everything laid out, I'm following the same basic labeling scenario for every drawer. That's to put a B on the back piece and on the outside side of the drawer. Put an F on the front piece and again on the outside of the drawer, and S's on the 2 side pieces, and I'm putting the S's at the end closest to the front of the drawer. Now all that may sound a little tedious, but it's going to come into play because of the way I'm going to cut these box joints. So let me show you how that's going to work. A box joint is really nothing more than a series of grooves cut in the end of one board that corresponds with a series of grooves cut in the end of another board. Cutting a box joint is just a matter of making a series of cuts, and typically that's done with a pin register type system, either on the table saw or at the router table. But it can be a lot of cuts. A drawer box, of course, consists of 4 separate boards, and there's cuts in both ends of all 4 boards. So that's 8 series of cuts per drawer box. I've got 7 drawers to do, so I've got a total of 56 series of cuts to make, but a wide or deep drawer could be an awful lot of individual cuts in each one. So that's an awful lot of cuts. Some time ago, I ran across a video that was done by Incra, and they were promoting their positioning system for both table saws and router tables. And they demonstrated on there how the cuts could be ganged and made all at one time for a box. And basically what they did was they stacked all 4 boards like this, and they offset these 2 boards the same thickness, the same amount as the thickness of the material. Then they put a sacrificial board on the front and on the back and ran this across the cutter, and they made the first cut, then moved it progressively the correct distance each time, and made each successive cut until they got to the end. And by offsetting the first cut, it made it come out right so that they would join together. Pretty neat. Could I adapt that to cutting plywood? Well, that's what I wanted to try to do. So let's see if we can get that done. The first thing that I did to get set up here was I chucked up a 1/2 inch bit. And I set the bit distance from the fence at precisely 1/2 inch. Height-wise, I've set the height first at a 1/2 inch and then lowered it a little bit to get it to just exactly the same height as the thickness of this 1/2 inch plywood, which is a little bit undersized. So it's just a smidge less than a 1/2 inch as far as the depth of the cut. So I've got that in position. I've also put a piece of blue painter's tape up here to correspond with when this fence mechanism gets even right there. So I'll know how far to go through without cutting into the wood on the underside of this fence. So let me show you the rest of the setup. I'm going to take the front and back piece, labeled, this is the back, this is the front, and I'm going to put them together with the labels facing out on both sides. And this is the top side, so I'm going to face the top to the fence. And I'm going to do the same thing with the 2 side pieces, labels out, tops facing the fence. And then I'm going to take the little spacer pieces that were cut off the end and then cut in half, they're the same width, and I'm going to put them on either side of this sandwich here. I'm going to push it all up next to the fence, and then I'm going to use a scrap of our same plywood that we're using. I'm going to offset this scrap and the 2 side pieces, just the thickness of that piece of plywood. And I'm going to clamp the entire sandwich together against this fence. The first cut will essentially bypass the 2 offset boards in the front and cut only the 2 boards in the back. Then, because we're making 1/2 inch notches, the fence is moved exactly 1 inch. The next cut will go through all 4 boards in the sandwich. Then, after each cut, the fence is again moved exactly 1 inch until all of the cuts are made. You will note that the sacrificial board on the front of the stack is taking quite a beating. The board on the back is too. That's why it's difficult sometimes to pull the fence back to get ready for the next cut. There are chips and plies from the plywood getting stuck around the cutter. As I got more practiced in this technique, I started lifting the fence up and off the rail and moved it back into position for the next cut. This worked much better. Okay, now I'm gonna turn these end for end. That's not terrible. Thanks for watching. See you in the next video.